Hello, this is a pre-calculus video, and today we're going to talk about how we go from Pythagorean's theorem to the unit circle. So, as you know, Pythagorean's theorem is c squared equals a squared plus b squared. So, for example, if a equals 3, b equals 4, what would c be? So, according to Pythagorean's theorem, it would be 3 squared plus 4 squared equals c squared. Okay? So 3 squared is 9 plus 4 squared, which is 16, equals c squared. 9 plus 16 is 25, equals c squared. So now we're going to take the square root of both sides. Square root of 25 is 5. Square root of c squared is c. And that's how you would find a missing angular side. Okay. So next, we're going to talk about special triangles. So there's the 30, 60, 90 triangle and 45, 45, 90 triangle. So basically, the 30, 60, 90 triangle is an equilateral triangle. So all sides are the same length and all angles are equal to 60 degrees. So basically what 30, 60, 90 triangle is, it's an equilateral triangle that's cut in half. So we have the 90 degree right here, and 60 divided by 2 is 30 degrees. Okay, so right here, let's look at one triangle. So we have our 90, our 60, and our 30. So Pythagorean's theorem, it would apply to this triangle as well. So this is C, and then this is A, and that is B. Okay? So if A equals 1, so if A is equal to 1, if all sides are 1 in the equilateral triangle, C would equal 1. So, to find A, we cut the one side in half, right? So, C is half of C, so half of C is 1/2. So we need to find B. So, just like Pythagorean's theorem, A is 1/2 squared plus b squared equals c squared. So since we don't know what b squared is, that's what we're trying to solve. Make this a 1, sorry. So 1/2 squared is going to be 1/4 plus b squared equals 1 squared, which is 1. So we have to get rid of the 1/4 on this side and bring it over here so we can get b by itself. Okay, so b squared equals 1 minus 1/4. So b squared is 4/4 minus 1/4. So that would equal to 3/4. So we have to find the square root of that. So let's move it over here. So b squared equals 3/4. You take the square root of both sides. So b squared, the square root of b squared is going to be b. The square root of 3/4 is root 3 over 2, because the square root of 4 is 2. And that's how you find the sides. Yes. Okay, so next we're going to talk about 45, 45, 90 triangles. Basically, it is a square, right? 90 degrees on all sides. and all the same length. So basically what it is, it's a square that is cut in half. So half of 9, we have a 90 degree right here. So half of 90 is 45. Okay, let's make a bigger version right here. So these sides are the same. And then we have the diagonal from the square. So C is going to always be the hypotenuse, C, and then you have A and B as your legs. So these are all the same length, so B equals A. So let's say if A equals 1, then B equals 1 as well. Okay, so we use Pythagorean theorem again, which is A squared plus B squared equals C squared. So 1 squared plus 1 squared equals C squared. So 1 squared is 1, plus 1 squared is 1 equals C squared. 1 plus 1 equals 2, C squared. Yes, and then we take the square root of that, and C equals radical 2. Well, the next thing we're going to talk about is the unit circle. And what the unit circle is, it's just a circle with a unit radius of 1. Radius of 1. Okay, so here's our y-axis, and here is our x-axis, and here is our circle. So here's the origin, and that's 0, 0. And right here is the point, which is 1, 0. Then on this side, the unit is going to be -1, 0. Yeah. And then right here, the unit is 0, 1. And right here, it's 0, -1. Okay. So in the unit circle, we have theta over here. And then if theta, so this is 1 radian. That's, yeah. So if theta equals 1 radian, then the arc, which is this, is going to be the radius. Yes. Okay, so the circumference of a circle is basically C equals 2 pi r. And so, because r equals 1, we could say that C equals 2 pi times 1. So it would just be 2 pi. So in a circle, there are 2 radians, which equal 360. Oh, okay. So 2 pi radians equals 360. Let's put that right here. Equals 360. Yeah, sorry. I don't know if you can see that. So we'll divide both sides by 360. And so 360 divided by 360 is simplified to 1. And 2 pi radians divided by 360 is going to be pi over 2 pi equals 360. Okay, so if we divide both sides by 360, this side simplifies to 1, and 2 pi over 360 equals pi over 180, and that equals 1 degree. So 1 radian equals to 360 over 2 pi, which is which is 180 over pi, 180 degrees, and that's approximately about 57.3 degrees. Right here, and let's make this 30 degrees. And so if we drop a line down here, it's going to make a right angle. So 30 and 90. Let me get one of those. So if this is 30 and that's 90, this has to be 60 degrees. So the unit circle has a unit radius of 1. So as we learned before, this is going to be 1/2, and this is going to be radical 3 over 2. So let's try to find this point right here. So how we do that is we find the cosine of 30 degrees. Right? So it's going to be adjacent over hypotenuse. So adjacent of 30 degrees is radical 3 over 2 all over the hypotenuse, which is going to be 1. So your cosine is radical 3 over 2. So that is going to be our x coordinate, radical 3 over 2.
Which
and
is
then
cosine.
Let's try to find the y coordinate,
Which is the sine.
Yes, so sine 30 degrees is going to be opposite over hypotenuse. So what that is 1/2 over the hypotenuse, which is 1. So it's 1/2. Yeah, 1/2. So you can see right here, this is the y coordinate, and then this is the x coordinate, and they meet.
Now
This
we
is
will
cosine
convert from degrees to radians. The conversion factor is pi over 180. We take 30 and multiply it by pi over 180, which equals 30 pi over 180. 30 over 180 is 1/6 of, it's 1/6. And we add pi because it moves over there. So it's pi over 6. 30 degrees equals pi over 6.
So if you follow all those steps that we just went over, your unit circle should look like this. Yes.
At the end.
And that is how you go from Pythagorean's theorem all the way to the unit circle.